Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, picture this. You're training an AI agent, not just answering questions, but debugging code, running tools, even navigating environments. It thinks, acts, observes, repeats dozens of steps, thousands of tokens, and then everything slows down. Not because of the model, but because your system can't keep up. This is exactly the problem explored in ProRL Agent, Rollout-as-a-Service for RL training of multi-turn LLM agents by Hao Zhang and Mingji Liu. They noticed something subtle but critical. In most RL systems, rollout, the part where agents interact with environments, is tightly glued to training. But here's the catch. Rollout is messy and I/O heavy. Training is clean and GPU heavy. Mix them together and both suffer. So they flipped the idea. What if rollout was its own service, not a function, not a module, a full system? That's ProRL Agent. Instead of the trainer doing everything, it simply sends a request. Here's a task, go run the agent. And the server handles the rest: environment setup, tool execution, multi-step reasoning, evaluation, then returns trajectories and rewards, like ordering food instead of cooking everything yourself. Now, inside this system, there's something elegant, a three-stage pipeline. Init, run, evolve. Init sets up the sandbox, run executes the agent loop step by step, eval scores the result. Each stage has its own worker pool. So while one job is being evaluated, another is running, and another is just starting. No waiting, no blocking, like a factory assembly line, always moving. But the real magic is in the environment design. They use sandboxed containers built with singularity, so everything runs without root access. Even on HPC clusters, each task plugs into a clean interface called Ardent Handler. Three simple methods: init, run, eval. That's it. Want to add a new task? Just write a new handler. No need to touch the training system. This separation is what makes it scalable. Then comes performance. Agents rely heavily on tools, running Bash, executing Python, editing files. Each call adds latency, so they optimize everything. Direct shell execution instead of tmux. Persistent Python kernels, so state is reused. Unix domain sockets instead of TCP. Tiny improvements, but across hundreds of steps, they add up massively. Now let's talk about LLM inference. When hundreds of agents run in parallel, you need multiple model servers. ProRL uses a min-heap scheduler. It always picks the least busy server and assigns the whole task there. Why? To reuse context and reduce recomputation. Simple idea, huge efficiency gain. And here's a subtle but powerful detail. They use token in, token out communication. No retokenization. Why does that matter? Because even tiny token mismatches can break RL training signals. This keeps everything perfectly aligned. Let's look at results. Across software engineering, math, STEM, and coding, performance improves consistently. Training curves rise steadily. Agents actually learn to use tools effectively over time. Pitfall: if rollout and training stay coupled, you'll hit scaling limits fast. Another one, ignoring tool latency silently kills throughput. Practical tip: design your system like microservices, not monoliths. So here's the bigger idea. This isn't just about RL, it's about treating interaction as a service. And once you do that, you don't just train better agents, you unlock entirely new ways to scale intelligence. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.